Hello, today we're going to be doing 2.7 graphing rational functions. There's 7 guidelines here to help us graph rational functions a little bit better. The first one is to simplify f, meaning you are going to want to factor both the numerator and the denominator, and you're going to reduce out any wholes. So wholes are going to come from factors that cancel from both the numerator and the denominator. So if it's the same thing that cancels out, that would be a whole. Anything left in the numerator is going to be a 0 or x-intercept. Anything left in the denominator is going to be a vertical asymptote. You're also going to want to graph any 0 as a coordinate point and any vertical asymptote as a dotted vertical line. You're going to want to graph any whole as an open circle on your graph. You're also going to need to graph your y-intercept, and that is going to be 0, comma, some number. You can find it by plugging in 0 for x and solving for y. And you're also going to want to graph any horizontal asymptotes. And you figure out your horizontal asymptotes by looking at the degrees of the numerator compared to the degree of the denominator. Once you've got kind of your guidelines, then you can go ahead and graph all of the other points using your graphing calculator to get the shape of your rational function. So let's take a look at that. For example 1 here, we have f of x. Our first thing is going to be to factor the numerator and the denominator. They both end up having a GCF of 2x in the numerator and x in the denominator. And then they both are going to be the difference of 2 squares. And so as we're looking at this, we first want to reduce out any wholes. I am noticing here that x is a factor in both the numerator and the denominator. So yes, there is a whole, and that is when x is 0. So to find my y value of my whole, what I'm going to do is I am going to rewrite everything after I have reduced the whole out of it. And then I'm going to go ahead and I am going to plug in 0 for x. So I get 0 plus 3 and 0 minus 3 and a 2 in the numerator, and a 0 minus 2 and a 0 plus 2 in the denominator. So we're doing 2 times 3 times negative 3 over negative 2 times 2. So in the numerator we get a negative 18 over a negative 4, which reduces to a positive 9/2. So 0, comma, and then just above 4, in between 4 and 5, 4.5 is going to be an open circle for the whole. Vertical asymptotes are going to come from the denominator set equal to 0, so we're going to do that after we've canceled out the wholes. We're going to get x equals positive 2 and x equals negative 2, and you do need to show those on your graph as a dotted vertical line. Your graph is going to get close to that, but it's not going to ever touch your vertical asymptotes. Your horizontal asymptote is based off of the degree. So if we go back to the original one, these degrees are equal. Because they are equal, what we're going to do is we're going to take the ratio of the leading coefficients. So it's going to be y equals 2 over 1 or 2. And you're going to graph that as a dotted horizontal line. It's possible that your graph might cross your horizontal asymptote, but it will only cross your horizontal asymptote close to 0. The horizontal asymptote is really defining the end behavior of your graph, like what's happening at the very, very right and the very, very left of your graph. Because there's a horizontal asymptote, there is no slant asymptote. Your x-intercepts now are going to come from the numerator set equal to 0. The 2 up there does not give you an x-intercept, but we should have negative 3 comma 0 and 3 comma 0 as our x-intercepts. And we can go ahead and put those on our point on our graph. My y-intercept, normally I would plug in 0 to find this, but if you go back to the original one, you would get 0 over 0. And if you look at the whole, the x-coordinate of the whole is 0, which means we're not actually going to cross the y-axis with an actual point. We have a hole there instead. Now to get the rest of our graph going, what we're going to do is we're going to go ahead and type this in on our graphing calculator. So we're going to have this. You want to make sure you have parentheses grouping your numerator together and parentheses grouping your denominator together. And then you're going to look at the second table. It's right at the same button as graph, and we're actually going to graph a bunch of these points, as many as we can in each region just to get a nice picture. Probably 2 or 3 is probably good enough. So we're going to do -4, and then 1.17. Another one was right here. We're just plotting all of the points that you saw on your table. And then after we get these, you can go ahead and once again go to your calculator and look at the graph of it, and you can see you have some like spaces vertically where your graph is not going to cross. So we're going to make our graph look like that. So we're just going to connect the dots here. And if for some reason your graph on your graphing calculator doesn't look like your graph on your paper, that's your indication that maybe something is going off, or maybe you need parentheses or something like that. And our last one here, the limit as x goes to infinity, it's saying on the right of your graph, way over here, where is your graph getting close to? And it is going up for forever here. It's getting slower and slower with how fast it's going up. But that horizontal asymptote is really what our graph is approaching. So our graph is approaching 2. So whatever your horizontal asymptote, that will always match your end behavior of your graph. And if we wanted to throw one more thing here, the domain, just to talk about it, from left to right, it's going to be everything except for the restrictions in the denominator. So that is going to include vertical asymptotes, but it's also going to include the whole. So it's going to be -infinity to -2, from -2 until 0, from 0 to 2, and 2 to infinity. Okay, so we're going to go ahead and we are going to try another one now. Let's go ahead and take a look at number 2. So for this one, we are going to go ahead and factor and simplify things. So the numerator here is going to factor. This one has no factors that cancel out, so there's no wholes. The vertical asymptote comes from the denominator. It is x equals -1. This one has no horizontal asymptote because this is top heavy. And when it's top heavy, it might have a slant asymptote if it's top heavy by 1, and that is the case here. So it's an x squared over an x. When it is top heavy by 1, we are going to do synthetic division, and we are going to figure out the equation of that diagonal line, which is your slant asymptote. So you do all of your synthetic division here, and whatever the remainder is, it truly does not matter. It's the other stuff we're looking at. This is going to be a linear equation, y equals x minus 2. And so that is going to be the equation of the line that we graph. And it should, your slant asymptote will always go at an angle on your graph. Your x-intercepts come from the numerator, so it's going to be 3, 0 and -2, 0. And we can go ahead and plot those. Your y-intercept is 0, and then the ratio of your constants, so -6. And at this point, as we're looking at the limit, we should go ahead and graph other points on our graph grid. So grab your calculator and type it in. Figure out a couple more points along the way here, and then what you're going to do is you're going to connect those points in a nice fluid curve. And so as you're looking at this, now the limit as x goes to infinity, that's on the right hand side, where is your graph going? We are going towards that slant asymptote, but that slant asymptote is going up to the right for forever. So your limit as you go to the right is infinity because your graph is going up. If I were to ask you the same question on the left, the limit as x goes to -infinity, our graph is going down on the left, so it would be -infinity. So we're going to do one more. We're going to write our own equation. We know it has to have a vertical asymptote of x equals 2, and vertical asymptotes come from the denominator, so it's going to be x minus 2 down there. Wholes happen when factors cancel, so we're going to have an x plus 1 in both the numerator and the denominator. The 0 here is going to be when x is -2, so it's going to be a factor of x plus 2. And lastly, the horizontal asymptote of y equals -3, that means I have to have the same degree on the top and the bottom, And then the ratio of my leading coefficients has to be -3/1. So I'm going to go ahead and put a -3 in front. And I'm going to say this is my equation of that rational function. You can always type that in on your graphing calculator and just see if it fits all of those different pieces of information. And if it does, it fits the bill, you're good. Thank you for listening. I hope this helped.